Good morning, everyone. Let's get started. So today we are going to learn about the Java recursion. Yeah, before getting into the details, some of you know already me, like some of you have joined previous of my classes. For those who do not know me, so this is Karthik. So I've been part of Ashok IT from past 2 years. I've taught various data structures, design patterns, core Java, advanced Java, threads, collections. So these things. So I've taken around 20 plus batches in the Ashok IT. And today I'm the one who is going to facilitate the free workshop on the Java recursion. So main topic I have taken this recursion means, can someone tell me anything? What is a recursion? What is a recursion? Yeah, any other answer, anyone?
The method which call itself is called recursion.
Yeah, the method calls itself. Okay. Any other answer, anyone? Okay. So if you are calling the same method within the method, it's a recursion. That is what the answer I can see, right? Yes, that is right. But whenever you are executing a recursion program, you do not know how the flow is happening and when the loop is getting break, etc. Right? So today we are going to understand that using a recursion can be used anywhere. If you are writing a Fibonacci series program, you can write using recursion. Reverse of a number, you can write using recursion. That means anything, whichever you are using a loop, you can write using a recursion as well. So today I'm going to explain something about tree. So tree is a data structure in Java in which whenever you are doing a tree traversal techniques, these recursions are used. So I can take some other example as well, but if I explain tree, since it is a data structure, you will be able to understand what is a tree and how can we do the tree data structure in order, pre-order, post-order traversals. So I'm going to explain the recursion in the tree. Now let us take, so tree is a data structure in Java. So we have, see in Java, we have a linked list, we have a stack, we have a queue. So linked list is a class, it's already present in Java, which is provided by Java creators. Similarly, stack is also a class extending from vector. Queue is an interface, linked blocking queue, array blocking queue, priority queue, synchronous queue. These are the queues provided by, which are implementing a queue interface. So that's already provided by Java. But when it comes to the tree, so we have a tree map and then tree set, but we do not have there is no class called tree in Java. Now, what is a tree? In a basic term, so tree is nothing but it has one root element, and then it has many childs like this. Each child can have multiple childs. So this is a tree data structure. Like this is how the tree data structure looks at it. Correct? Now, so this is a tree in Java generally. Now, there is one concept called as binary tree. So first I'm going to explain what is a tree, what is a binary tree, how to construct a tree. And then whenever you're going for a tree traversal techniques, which is nothing but in order, pre-order or post-order, we are using a recursive. So if I explain that time, then you will understand the tree data structure as well as you will understand the how does the recursion is going to work in Java. Correct? So that same thing you can apply for any of the recursion program like reverse of a number, Fibonacci series, anything. Okay, what is a binary tree? A tree can have, see, if I take this is a parent, can someone tell me how many childs are there for this? How many childs are there for this?
4.
4, correct? 1, 2, 3, 4. Right? Here, a tree can be called as a binary tree only when the root should have only 2 childs. For example, this one, I am taking this. So can I say only 2? Yes. So this is a parent. This parent has 2 childs only. Now, can this also be a parent? Yeah, for example, if you look at your grandfather, like we have our father, right? So grandfather has 2 kids, might be your father and your auntie. And then your father is having, might be 2 kids, right? Same thing. So for this parent, there are 2 childs, correct? And for this parent, again, 2 childs might be. That means a tree can be called as a binary tree only when each parent can have maximum of 2 childs. And see, there should not be a third child like this. No. Here, if you look at the tree here, 1, 2, 3, 4, 4 childs are there. No. A tree, a root or a parent should have only maximum of 2 children, or it can have 0 children also. For example, now see, this is a parent, this is a parent. Can this be a parent? No, at this point of time, it's a child. Now, can it have only one parent, one child? Yes. Can it have only one child? Yes. Now, does this have any child? No. That means a tree can be called as a binary tree only when each node should contain maximum of 2 children, or it can have only one children, or it can have no children. Here, if you look at here, for this, are there any children for this? No. If you look at this node and this node, do I have the children? Yes, this is a right child, this is a left child. So what is a binary tree? A tree can be called as a binary tree only in which maximum number of 2 children are present. And that binary, see, can I call this as a binary tree? Yes or no?
Yes.
Now, can I call this as a binary tree now?
No.
No, sir.
Now, can I call this as a binary tree?
Yes.
Yes.
Can I call this?
Yes.
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 This one?
Yes, sir.
Yes, sir.
This one?
Yes, sir.
This one?
Yes, sir.
Okay. Now, can I call this as a binary tree?
Yes, sir.
Yes, sir.
Can I call this as a binary tree?
Yes, sir.
Can I call this one?
No.
Yes, sir.
Yes, it can have 1 or 2 or no, correct?
No, yes, sir.
Yeah, here no kids, no children are there. Here 1 children, here 1 children, correct? So the difference between a tree and a binary tree is a tree can have any number of children, but a binary tree can have only maximum of 2 children, or it can have only 1, or it can have 0, right? That means it can have 0 children or 1 children or 2 children. Can it have beyond 2? No. Now, whenever you have 2 children, so can I call this as, if you take this side from this root, can I say this is what direction? Is it in right direction or left direction?
Left directions.
Left, correct? And this one?
Right direction.
Right.
So this is called as a right child. This is called as a left child, correct?
Okay.
Yeah. So whenever you take a root, now can I say this is a parent? Again, to this parent, this is a left child, and this is right child.
Right, sir.
This is a parent. Now, can I say this is a top parent?
Yes,
If
sir.
you take the hierarchy of your family, who is your head of your family?
Grandfather.
Grandfather, right? Or grandfather can also see sometimes your 4th generation is also possible, correct? Your father
sir.
of your grandfather is also alive. So you can say your father of your grandfather is your head of your household. That is called as a root. Here in this entire tree, see, this is a parent, this is a parent. Can I say this is, can I say 1 generation? This is 2nd generation, this is 3rd generation, correct? So for all this, what is a parent? Till here, what is a parent? Can I say this node? So
Yes,
the
sir.
top parent is called as root. In tree, there are some terminologies. What are the terminologies? Root, left, right. Root is nothing but a topmost element. And then any element that is left side is called as a left child. That is also called as a left. Right child is also called as a right. So this is about a tree terminology. Now, if I want to construct a tree, now I have let's construct T 10, 5, 7, 8, 9, 0, 1. Correct? Now, can I call it as a tree?
Yes, sir.
Can
Yes,
I call
sir.
it as a binary tree?
Yes, sir.
Yes, sir.
Now I have shown you in this diagram. Now can I say that how, see, for linked list, we have a class called linked list in Java. You can use it, right? For tree, do we have a class called tree in Java?
No.
We do not, right? Now the question is, how can I represent the tree in the data tree in Java, right? Now this diagram, whenever I have drawn this diagram, it's good. But how can I represent this tree? Now let us do that. Okay. Now I'm just creating a new project. I hope you are able to see my screen, right, everyone?
Yes, sir.
Yes, sir.
Yeah, thank you. So I'm creating a new Java project. I'm naming it as Java Recursion. Guys, this video, I mean, like, this class is getting YouTube live as well. If you are getting disconnected, you can watch it. Or if you want, and since it will be there in the YouTube, you can watch it later point of as. Like if you want to revise it, you can do it again. So let me create a package. Package name should be what letters, guys? Is it capital or small?
Small letter.
Small.
Small letter.
Small letter. Okay, let me create a class called tree implementation. Okay, now let us see. So in order to, can someone tell me what is the shortcut to see the predefined classes in Java? I mean in Eclipse. What is the shortcut to see predefined classes? Control Shift
Control
T.
space.
H.
Yeah. Control Shift T. See here, if you look at here, do you see tree class? Only tree? No. I have a tree map, I have tree set, something, all the others are there. But do I have only tree? No. But if you look at linked list, do I have a linked list? Something? Java.util package. Can I say it's a class? Yes.
Yes,
So
sir.
linked list is a class provided by Java, but we do not have a tree data structure inbuilt. So now it's our responsibility to create a tree data structure. So now, how can I represent a tree data structure? To represent this one, so here we use an inner class called as a node. Static class node. This class name can be anything. I can keep the Karthik also. But general naming convention that is followed is node. Okay. Now here, can I say in the root node, what are you storing in the root node? What is the value of root node?
10.
10. So that means in this node, I have to have some data, correct? So it can be, see, in this example, it is 10. Now you can put some alphabets also, correct? Anything. So that's the reason I can take object data. Okay. Now, so here, if this is a node, can I say this is also a node? This is also a node. All these are in this tree. Can I say all are node objects only?
Yes, sir.
But what is the relation? For 10, 5 is a node object, 10 is a node object. 5 is towards what side of 10?
Left side.
Left side. 7 is what side of 10?
Right side.
That means for each node, you have to put left side and right side, if possible, correct?
Yes.
So in order to do that, can I say I have to take again the direction? Node left, correct? Node right. So this, because if you look at here, as I mentioned that everything is a node object. This is also a node object. This is also a node object. So, but this node is towards left side. So that's the reason I'm using the same object reference here. And then I'm putting left. Now let me take the constructor. Because I need to create an object means I need to have a constructor. Object data. This dot data equal to data. Done. Now let me construct a tree. Now, in order to construct a tree, what should I do? I will create a class. I mean, object of this one, T equal to new tree implementation. Now, T. So what is the first topmost element is called in the tree? What is the topmost element is called? Just now I explained.
Parent, sir.
Node.
It's a root, correct?
Root. Okay.
Yeah. So it's a naming terminology. You can use something else also. but this is the naming that will be used throughout the data structure. Okay. So can I, that root is also a node object, yes or no?
Yes.
Yes.
That means it's a node
Yes.
object only, but you are naming it as a root. The reference variable is root. So now let me keep node root. Correct? Done. Now t dot root. So in this example, what is the root value, guys?
10.
10. So in order to create a 10, where should I store this 10? Inside a node object, correct?
Yes.
In order to store the node object, can I say I have to create a class? I mean, like class is present. I have to create a object of this node class and pass the 10, correct?
Yes, sir.
So new node of 10. So can I say that first I have created a root node?
Yes, sir.
Now, next. So what is there towards right side of your 10?
5.
5. First of all, you need to create a new
Yeah.
node with a 5, correct? New node 5. Yes, I created a node object. See, as I mentioned, everything is a node object, correct? Now, so now by writing this line of code, what does it mean? Can I say I have created a node object and which contains the node data as a 5? Yes or no? Did I create a node object for 5?
Yes, sir.
Yes. But where should I keep this, guys? Is it towards what side? What direction of 10?
Left side.
Left side of 10, correct? Now, can I say your left here, 10 is nothing but your root, correct? Can I say t dot root dot left equal to new node of 5? Am I right?
Yes.
Now, similarly, if you say right side, what is the right side first? 7. 7, with the 7 value, I have to create a node object, correct? Now, can I say new node and 7? Now I should place these two towards right side
Right
of
side.
10. How, what is your 10? 10 is nothing but your root, correct?
Right.
Root dot right, correct? Done. Now here, if I go to the remaining, can I say 8? 8 is a node, correct? First, let me create a node. New node of 8. Done. So where is the position for 8, guys? Always I'll start with this node only, correct? Now, how can I go to the 8? Root dot right dot right. Am I right? Sorry, my
Left.
mistake. Root left dot left, correct? Say root dot left. And again 5, 8 is what side of 5? Left. Can I say root dot left is nothing but 8?
Yes.
Yes.
Does everyone agree?
Yes, sir.
Yes.
Now let us do t dot root dot left equal to new node of 8. Done. Now what is this 9? Again, I will create a new node. New node followed by 9. Done. Now how can I add 9?
Root dot left dot right.
Root dot left dot right. Correct. Let's copy this and I'll change it to right. Correct. So can I write the remaining? Remaining means 7 we have done. What about 0? New node of 0. Where is 0 should come?
Root right.
Root
Root
dot
dot-
right dot left.
Left.
Yes. Root dot right dot left. Okay. Next. What is the next value? 1. With 1, I will create an object first. Done. So what is the position for 1?
Root dot right dot right.
Yes. Root dot right dot right. Okay. Now let us do sys out hi. Now let me debug the program and see whether the program looks like the same or not. Right click, debug as Java application. So I'm just debug directly. I'm going to this line. Now, if you look at the root, what is the root element, guys? in my example?
10.
10. Let me minimize this and show minimize this as well. Let me put these two side, or else let me take snipping. Just give me a minute, guys. I'm just putting side by side both. Now, if you look at here, what according to the diagram, what is the root? 10, correct? See, can I say 10 is my root? Now, what is the left of 10? 5. So look at here, expand it. What is the left of 5? What's left of 10? 5. What is the left of 5? Look at here again, root node object. It's 8. Does 8 has any left and right? Quickly.
No.
No. Can I say left and right of 8 is null? Done. Now, what is the right of 8? 9, correct? Sorry, right of 8 is nothing. For right of 5 is 9. Does 9 has any left and right? No.
No.
Okay. Now let's go back here. So 10 right is 7. 7 left is 0.
0.
And 7 right is
1.
1.
yes. So 1, does 1 and 0 has anything? No. You see left and right
No.
is null. Here see left and right is null, correct? That means, can I say I have represented, see, though I'm not able to see in the Eclipse, can we see the diagrammatic approach? We may not. But can I say that I have implemented the same thing?
Yes, sir.
Yes.
So this is how you can implement a basic tree, how to implement a basic tree in Java. So see, if the tree is big, I understand that writing like this is not an approach. That's where you go for a binary search tree or some logic, some comparator logic. That's all different. Now we know the tree. Now, if I give you the array, guys, let me ask you one question. If I have you, I have this array. So if I'm asking you to traverse over array, how do you do? 5, 10, 5, 3, 2, 1. I'm asking you to write a, can you please traverse over the array? What do you do?
For loop through, sir.
Using
For loop, sir.
Loop.
for loop, correct?
For loop.
For loop.
You might be using a for loop or any
Can I
other
have for
loop, while loop or something, correct? Okay. Now, if I ask you, see, where do you start your for loop? Can I say this position, which is nothing but 0, correct?
Yes.
Array position starts with 0. Now, if I ask you to traverse this tree, how do you do? Can you use a for loop?
No, sir.
I mean, you have to, when I say you are traversing, you should go to left, right, left, everything. You should cover all the nodes, correct? So simple for loop is not going to work. And see, I have to start with, I know that I have to start with root node, which is nothing but 10. But does it have an index 0, 1, 2, 3 like that?
No, sir.
No.
Because it's not an array. So that's where the tree traversal will be different. So in order to do the traversal of a tree,
Recursive.
we have some algorithms called in order,
Post.
pre-order,
Restore.
post order. So what is the in order is telling? You start with a root. All the in order, pre-order, post order, start with a root. In order is telling you that start with a root, go to extreme left, root, right. This is a passion how the in order will work. In order means go to left, extreme left, and then root, and then right. Now, let's write the in order traversal for this one. So I'll start with root. Can I say that 10 is the extreme left? How do I know whether it's a extreme left or not?
So if we are not finding any element.
Any element towards the left side, correct? Left,
Yes,
I'm saying
yes.
extreme left. Now, do you have an element towards left side of 10?
Yes. Yes.
Can I say that this is the extreme left? No.
No.
Then go here, 5. So can I call this 5 as the extreme left?
Yes.
No.
No, because 5 is having a 8 as a left, correct? Now, let's go to 8. Does 8 has anything left?
No.
No.
That means, can I say it is null? So so generally we don't print null. So that means, can I say I have reached extreme left?
Yes.
So 8 left side of 8, what is the value?
Null value.
Null. So generally we don't print it, but put null. So what is the in order it's telling you? Go to the extreme left, then print it. So that means you have reached extreme left. Then after that, what it is telling you? Root. See, extreme left is null. Done. After that, what is the root? Can I say 8?
Yes.
Yes.
What is the right of 8? After that, right. What is the right side of 8?
Null.
Nothing, sir.
Null. But we don't print it. Okay. Now, can I say this tree is covered now?
Yes.
Now,
Yes.
once this tree is covered, see, as the in order is telling, left, right, left, root, right. Left, root, right. Okay. Now, if you take this is a this tree. If you take this is a tree, okay, can you say this is a subtree? The blue color I have written.
Yes.
Okay. In this subtree, can I say did I cover left side? 8. Correct.
Yes.
Now,
Yes.
after that, where should I go?
Right side.
According to the logic, right root. Correct.
Root.
So what is the root? What is the root of 8? Which is nothing but 5. Correct.
9.
Done. And then right side 9. Done. Then again, if I take the whole tree, for this whole tree, can I say this is left? Whatever this blue color, this one, can I say this is a left is covered?
Yes.
Left subtree is covered or not? Everyone?
Yes, covered.
Yes.
Then after that, where should I go?
0. Right side.
Root side. Root.
Root.
Left,
Root.
root, right. Root. What is the root? 10. Correct.
10.
And then coming to the right side. Right side also you have a subtree. Correct. Can I write directly? No. I have to again same logic. Correct. See. Right side. Whenever I'm coming to the right side, I have to follow the same logic. Can I print directly? No. Again, so whenever you're coming right side, you have a node. So for this, you have to go to the extreme left, correct? So what is the left for 7? 0. Does the 0 has anything left?
No.
No. Can I take 0 now?
Yes.
0. And then after this is completed, what is the root? Left is completed. What is the next?
7.
Root. And what is the right?
1.
1. Can I say I have covered everything?
Yes.
So that means what is the in order traversal of this tree? 8, 5, 9, 10, 0, 7, 1. Correct? 8, 5, 9, 10, 0, 7, 1. So the in order traversal is telling you left, root, right. I hope everyone understand.
Yes.
Does anyone has any questions? We will, if no question, then we will represent this in the coding. But everyone understand?
Yes, sir.
Okay. So I take that silence as a yes. So now let's implement. So in order to implement this in order traversal, we use a recursion algorithm. Let's see. So can you say I have to write public void in order? Now, where are you starting the in order, guys? Which node?
Left side.
You are starting with, whenever you are starting the logic, you started with the 10 and you went to 5 and then you went to 8 and 8 dot left is null. That means always you will start with a root node, correct? Starting point is root node. From there only you will going towards the left or right and all, etc. Done. Now, if for example, if I am creating it, see here I have a node. Now, if I do not write this code, what does it mean? What is the value of my root? If I do not write this, I have commented this code. What is the value of my root? What does the root will hold? Null, correct? Root will hold null. So if it is a null, root value is null. Do I need to, if my root itself is null, that means can I say that I have a representation, but I do not have the values. So do I need to traverse anything? Not required. If the root is not equal to null, then only I have to traverse. Agree with me?
Yes.
Yeah.
Yes.
Yeah. So let's write if root not equal to null. Okay. Then what am I doing? See here first 10.
Left
You are
dot.
starting with a 10. So 10 dot left, is it null?
No.
Okay. And then you're taking the value as 5. 5 dot left, is it null?
No.
And 8. 5 dot left is 8. 8 dot left, is it null? Yes. Then
Yes.
you're printing. Then you're printing the node, correct? Root node, right? So that means I have to go towards first I'll check. Now here in this scenario, what is my root node? Can I say 10? 10 is not equal to null. Can I say I have to call the same method in order? I'll call the same method root dot left, correct? And then once this is broken, I will print system.out.println root dot data. And then I'm going towards right side in order root dot right. Now let's see how it will transfer. Let's see. So this is a recursion program. Now, if you look at here, this program, can I say line number 29 and line number 32 are calling the same method?
Mm,
Can I say yes or no?
Yes, sir.
Yes.
So the method which is calling the same again and again, you are calling the same method within the block, within the method is called as a recursion programming. Now let us debug the code and see how it will work. And whenever we are debugging, let us see whether we understand the code or not. Let me call this method from the main method, right? T dot in order and T dot root. Let's debug the code. Debug as Java application. So let's click F8. See, can I say first what is the root, guys? Can I say root is 10? Okay. Is the 10 not equal to null? True? Quickly. Is
Yes,
the
sir,
10
true.
not equal to null? Yes, true. So it will go inside. So immediately, what do you think, guys? From line number 30, again, it will go to this method.
Only.
Yes.
Yes, and then you're passing what you are passing, root dot left. Root dot left means what? 10 dot left, which is nothing but 5, correct?
Five.
You are passing 5. But what about these lines? See, from this line, the same method is getting called. But when this lines comes, later point of time. But if you debug it, you will not understand. Let us look at here. From this line, if I go again, root dot left means I pass 5, correct? Now, is 5 not equal to null? Is it true?
Yes.
Okay. Now, when it is true, again, you are calling the same method, correct?
Yes.
So whenever you're calling the same method, 5 dot left is what?
Yet.
5 dot left is 8.
Yes.
5 dot left is 8. So
Yes.
you call the same method. What is the value of root? 8,
Five.
correct? 8.
Perfect. Eight.
Yeah. Now, whenever you call the same method, 8 dot left, what is the value?
Null.
Null. So can I say it will break the loop?
Yes.
And then whenever it is, that means from this line, it is calling the method, correct? And it is breaking. And then where it will go? It will go to the line number 31. Look at here. But do you understand why it is going? Do you have a confusion now? Why it is going to the line number 31? You might have a confusion. Yes or no?
Yes.
Yes. Now again, if I debug again, it will go to, see, it is behaving in a different manner, correct? See, it's behaving different, correct? But do you understand this? If I debug, are you able to understand? My question is, are you able to understand? I'm going to explain, guys, but just answer it. So you will not be able to understand by, I see some responses in the chat that if I debug in a Eclipse, you are not able to understand, correct? Now let us write the algorithm for this. How does the recursion is going to execute? Let us stop it. Okay. Now let us take notepad. Yeah. So now let us write this. I'm calling this method. Let us write the algorithm. So can I say in order? What are you passing, guys? Whenever you're calling from main method, what is the root node? So guys, I need some volunteers who can actively speak with me. If whoever is comfortable, please volunteer for yourself. Because if I explain continuously, I can understand. I know all this very well. But if you make it as an interactive session, then you will understand, guys. That is the reason. Who can volunteer with me, guys? Anyone? Yeah, fine.
Yes, sir.
So what is the root node?
10.
10, sir.
10, correct? Yes. Now, how does the code looks like whenever I right click? First, so can I say these 4 lines I have to write?
Yes.
Yeah, let me copy it. Correct, done. Now, root is nothing but 10. 10 is not equal to null. Is it true?
Yes.
Yes, sir.
So
Whenever it is true, you will go inside this. Can I say these lines will be copied as is? Even compiler also will see all these lines, correct?
Yes, sir.
Yeah.
Yes.
Here in all these places, can I say my root will be replaced with a 10?
Yes, sir.
Yes.
Here also 10, correct? This is how first the compiler looks at it, correct? But from this line, what does it mean? You are calling the same method, correct?
yes.
So 10 of left means what?
5, sir.
Just remember this diagram. 10 dot left means 5, correct? Now, yeah, 10 dot left is 5, correct? So you are calling the same method. Can I say again this method will be, you are calling the same method like this?
Yes.
Yeah. So whenever you're calling the same method, can I say all these 4 lines will be executed again? Yes or no?
Yes.
If I have to write if root not, let's copy this. Okay. Now what are you passing here?
5.
So root is nothing but you are passing 5. 5 not equal null. Is it true?
Yes,
Yes.
sir.
Whenever it is true, again these 3 lines of code will be copied. Agree with me?
Yes.
Yes.
Okay. Now here, can I say here root will be replaced with a 5?
Yes.
Here also?
Yes.
Here also?
Yes, sir.
Yes. Done. But 5 dot left means what according to the diagram?
8.
8, sir.
8, sir.
8. But
8.
from this, that means from this line, see, you remember guys, these lines are there, but I'm not going to that line because you're calling from this line the same method. So 5 dot left means 8. You're calling the same method. Can I say again further it will call?
Yes.
Yes, sir.
So when this the below lines will execute whenever this loop is broken, correct?
Yes.
Yeah. Whenever it is calling, can I write if root is, what is the root value? 8.
8.
8 not equal to null.
Null.
Then what are you doing again?
Again, they will.
It will call.
You will call the same,
Sir.
correct? Now here, can I say 8 root will be replaced with 8?
8.
Yes.
Yeah. Here root will be replaced with 8.
Yes, sir.
Here also root will be replaced with 8. Yes. But from this line, again, you are calling the same method. Am I right?
Yes.
Yes.
Now, whenever you are calling same method, 8 dot left is what?
Null.
Null, sir.
Null. Now, whenever I'm calling, can I say again, first condition, what is that inside the method? If null
Yes.
not equal to null, correct?
Condition.
Why null? I'm doing because 8 dot left value is null. Now, whenever null dot null not equal null, is it true or false?
False, sir.
So that means you are not, whenever the condition is false, are you going to execute, call the same method further again?
No, sir.
So that
No.
means, can I say this loop is broken now?
Yes.
After this, what is the next statement you have? Can I say
System.
system.out.println?
Data printed.
Yes, sir.
What it will print? 8.data means, can I say it will print 8?
No.
No, sir.
8.data means root is 8.
Wait.
I mean, the node object is 8. Inside the data is nothing but whatever you are passing to the constructor, correct?
Yes.
So it will
Yes.
print 8. So the output is 8. Done. Now again, can I say in order 8.write? In order 8.write means what? You are calling the same method, correct?
Yes, sir.
Yes, sir.
Now, can I say here from this again, the method will be called?
Right.
Yes. Now again, you will check 8.write. What is the 8.write?
9.
Right.
Null. 8.write. Do you have any
Yes,
note?
sir.
Null, sir.
Not.
So 8.write is null. Null not equal to null. Will it break?
Yes.
That means it will not further break into other methods, correct? Now,
Yes.
once that is done, can I say this close bracket, this close bracket? What is the next statement? Can I say system.out.println 5.data, correct?
Yes.
Yes.
Why this 5.data is there? Whenever you are doing recursion,
Hmm.
the same method is calling the method, but remaining lines are there still in the down, correct?
Yes.
Yes. Now 5.data means what is the output?
All right.
5, sir. 5, sir.
Can I say 5? Yes.
Yes.
Now again 5.write. Can I say you are calling the same method?
Yeah. Yes.
So again 5.write is nothing but what?
5.write means 9.
9, correct? Yeah. So if 5.write is nothing but 9, correct? Let me write here 9. 9 not equal to null. Is it true?
Yes.
Yes, sir.
That means again you will divide further, correct?
Yeah.
So further means what happens? In order,
In order.
9
9
dot left, 9 dot left, sys out, 9 dot data, in order, 9 dot write, correct?
Yes.
Am I right? Yeah. Now from this line, can I say I will call the same method again?
Yes, sir.
Yes, sir.
But what is the left side of 9?
Null, sir.
Null. So null not equal to null. Can I say it will break?
Yes.
Yes, yes.
Yes.
So then what it will print? It will go to the next statement. What is the next statement? Sys out, right? Sys out means it will print 9.
9.
9 dot write. What is the output? I mean,
Null.
it will call the same method. Null not equal to
Null.
null. Can I say it will break again?
Yes.
Yeah.
Then where it is going?
System printed.
Dot 10 dot data. 10 dot data means it will print 10. And then it will go towards 10 dot write. 10 dot write means again method recursion, correct?
Yeah.
See, look at here. That small method is getting called so many times, right?
Hmm.
So 10 dot write means what?
Right means
7.
7, 7.
Yeah. If 7 not equal to null, is it true?
Yes, sir.
Yes, sir.
Yes. True.
Again, can I say it will be further divided?
Yes,
Yeah.
sir.
In order 7 dot left, sys out. Tell me, sys out 7 dot data.
Data.
Yes, sir.
In order 7 dot write, correct?
Yes, sir.
Again, so that means I have written all the lines, but from this line, it is calling a recursive, correct? From this line, it will be broken again, right? What is the 7 dot left?
0.
0.
If 0 not equal to null, is it true?
Yes, sir.
Yes.
Then again it becomes
In order.
in order
0
0
dot
dot left.
Sys out.
left.
See, I am writing the remaining statements and then these statements, correct?
Yes.
0 dot data in order 0 dot right, correct?
Yes.
But from this line, 0 dot left, what is the value?
Null, sir.
No.
If null not equal to null, can I say it will break?
Yes, sir.
Yes.
And then what? It will go to this line. What is the output it will print?
Yeah. 0.
0. In order 0 dot write, what is the value?
Null.
Null, sir.
Null not equal to null. Is it true?
Yes, sir.
Yes, sir.
False.
False.
It will. That means it will not divide the method further, right?
Ah,
Now can I say next statement? Sys out 7 dot data. Can I say it is print? It will print 7.
yes, sir.
7 dot write.
Side element is
1, sir.
1. Correct? Yeah. 7 dot write means 1. That means if 1 not equal to null.
Condition true.
Yes, condition is true. See, that's the reason. If you look at the brackets I'm putting not from starting, correct? According to the method I'm writing, in order 1 dot left, correct?
Yes. Element.
In middle, sys out, correct?
Yes.
Sys out 1 dot data and 1 dot right. 1 dot left, what is the value?
Null.
If null not equal to null, can I say it will break?
Yes.
Sir. False.
False. It will break. Then it will print 1 dot data, 1. And 1 dot right, it will
Null.
break again. Right? If null not equal to
No.
null, it is false. Now what do you have? Anything? Done. Correct? Can I say
Yes.
this is how? So if you look at my algorithm output, first 8, then 5, then 9, 10, 0, 7, 1. Correct? Now let us debug the program and see whether Eclipse is also doing the same way or not. I hope you guys understand whatever I have written.
Yes, sir.
Yes, sir.
So this is called a recursion algorithm. If you debug directly in the Eclipse, we do not know how the flow is happening, correct? Now
Yes,
let
sir.
us do it from here. Let's compare. Now first, whenever you're calling this method, let me make it as small. Okay. If I debug, see first, what is the root?
10 is a root.
10. Okay. Now I'm going from 10 dot left. Correct? 10 dot
Yes.
left means again, what happens? 10 dot left is 5. See, look at
5.
here, 5 not equal to null. Is the same thing 5 not equal to null?
Yes.
Yes. Again, 5 dot left. Correct? See, in order 5 dot left. 8.
Yeah.
8 not equal to null?
Yes.
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 Again, 8 dot left.
Null.
Null.
See, 8 dot left. Whenever the 8 dot left here, null not equal null, it is false. That means it is coming
False.
out. Next, what is the statement is executing? Sys out. Correct? Now from this line, you will go here. Can I say this condition is broken?
Yes.
Now it will
Yes,
come
sir.
out. After coming out, what line it is executing? Look at here. According to your logic, whatever the code you have written, system.out.println 8 dot data. Same thing?
Sir.
Yes. Now from in order 8 dot write. Can I say 8 dot write is nothing but null?
Yes,
Right?
sir.
Now it will come out. And then where it is going next time? System.out.println 5 dot data, correct?
Yes.
Yes, sir.
See, it is going system.out.println 5 dot data. Root is nothing but your 5, correct? Is it following the same way that I have written the algorithm?
Yes.
So that means if I debug directly, do you understand?
Yes, sir.
Yes, sir.
I mean, if I debug directly without writing, will be able to understand?
Yes, sir.
So first time it might be confusing, but whenever you write a recursion algorithm, you can understand, right? Now from this again, see 5 dot write done. 5 dot write. See, look at here. 5 dot write means 9. See, look at here. 9 not equal to null. Is it true?
Yes.
Yeah. So can I say again, it is coming inside this 9 not equal to null, correct?
Yes.
See, 9 dot left is null. Again, it
Null.
will break and then it will print 9. See, it is printing 9. 9 dot write null. It will come out of the loop. And then where it will go? 10, correct? See, it is printing 10. It is printing 10. Now then you are going to 10 dot write. Look at here. What is the root?
7.
10. 10 dot write is nothing but 7, correct? 7 not equal to null. Yes. Again, 7 dot left you are going. Look at here. Root dot left. Root is nothing but 7. See, 7 dot left is nothing but 0. You will go to 0. See? See, and 0 dot left, null. So it will come out. And then it will print 0. Look at here. It is going to system.out.println. And this is my statement here. I hope everyone is following me.
Yes.
And right is done. It will come out. And then where it will go? It will go to 7. System.out.println 7. See 7. And then it will go towards right side of 7, which is nothing but 1. 1 dot left, null. Then it will print 1. See 1 dot right, null. It will come out. So can I say it is coming out of the loop? See, after 1 dot right, there is nothing. So it is coming out of the loop, right? So this is how the recursion algorithm works in Java. This is not only for tree. Even if you write, can I say that reverse of a number, Fibonacci series, can we write using recursion?
Yes, sir.
Yes.
So same thing you can write like this in a notepad. First you write in notepad and then compare it with a Eclipse debugging structure. That means, can I say this is how the Eclipse is understanding internally? Yes or no? This is how the internally Eclipse is also executing, correct?
Yes, sir.
Whenever
Yes.
you are calling. So that is nothing but this is nothing but recursion algorithm. This is called as a recursion. This is how you need to understand how the recursion is happening in Java. Okay. So recursion is not nothing but just calling the same method. No, there are so many things, right? If you see, if you explain calling the same method, yes, but do you understand the flow before I explain? See, whenever I debug before the writing the algorithm, do you understand why suddenly this line is coming, why suddenly this coming, and what is the value of root every time? Do you understand? Yes, no? Before explanation, it was little difficult, right?
Yes,
Yes.
sir.
So for every recursion algorithm, you need to write the algorithm like this. Any questions? Does anyone has any questions on this recursion algorithm?
No, sir.
Got it.
Yeah. So similar to this recursion algorithm, so I started the data structures and algorithms, guys. So let me show you guys the course content. So data structures and algorithms. So I have I've divided these data structures and algorithms into two parts. One is collections, and then is advanced data structure topics. We just completed the collections, and then we started with the data structures. In the data structures, we are going to see time complexity, space complexity, all the sorting mechanisms: bubble sort, insertion sort, selection sort, merge sort, quick sort, heap sort, max heap, min heap, graphs, dynamic programming, matrix, pattern printing, and there are so many questions. Linked list programs, tree programs. See, look, and you can print all the leaves of a binary search tree, height of a tree, depth of a tree, level order traversal, vertical order traversal. And then we are going to solve all these HackerRank programs in the live class. So this course is started on 26th of July. We just completed the 3 classes, 26, 27, 28. And Monday is also there is a demo class. Okay. Now I'll be sharing, just give me a minute. Let me share the recordings of the classes. So if you guys are interested to watch it, you can watch this. And there is Monday also, there is one more demo session is going on. If you want, you can attend. So these are the, whatever I have pinged it, right? So these are the demo class videos. You can watch it. Okay. And the fee for this course is only if you want to join the data structures live classes, it is 5,000. If you want a backup videos, then it will be 8,000 and 10,000, including the total batch. And the timing of the course is morning 7:15 a.m. to 8:15 a.m. And these data structures we are going to complete within 45 to 50 days. That means we are end of July, right? In the mid of September, we are going to complete this course. Okay. So this is the course that is going on live. So in this one, I'm going to explain like I have explained the tree, right? We are going to see level order of a tree, in order, pre-order, post-order, print all, what is a binary search tree, print all the leaves of a binary tree, height of a tree, mirror image of a tree, binary tree path, level view of a tree, check whether the given tree is a binary search tree or not, mirror image of a program. So, and we are going to see linked list. What is a merging, two-way merging, open close bracket using a stack, comparing two linked lists, merging two linked lists, and there are LCM of two numbers, GCD. So there are so many questions we are going to see. So if so I'll just share. If anybody is interested, this is an inquiry form. I'm putting in the chat. Whoever is interested, can you please fill this form? Whoever is interested, I have shared one Google form in the link. Sorry, Google form link in the chat box. I request you guys to please fill the form while I'm on the class. And in future, in the August second week, I'm going to start with Java 8, 9, 11. See, it might be from August 16th. So I'm going to start Java 8, 9, 11. If you are interested, you can join that too. But currently, I'm taking the data structures, and whoever is interested, please fill the Google form. I'm pinging the Google form link in the chat and open for questions. Does anyone have any questions? Does anyone have any questions? How do you feel, guys? Do you understand the concept here? What is the recursion? How does the recursion algorithm works in Java?
Yes, sir.
Yes.
Yeah. So if anybody is interested, I request you to please fill the Google form link. I'm pasting the Google form link in the chat again. Okay. So if no question, that's all for today, guys. But if anybody is interested, please fill the Google form. I see no responses. If anybody is interested, please fill it. I'm sharing it again. Okay. So if no question, that's all for today, guys. Thank you all. Thanks for joining. Have a nice day. Thank you.
Thank you, sir.
Thank you.